Hey, welcome to iFlip for Math, Mathcast, Lesson 6-2, Patterns and Expressions. I'm Mrs. Gooding, and one of the students on our team came up with this quote, ask a question, then another. You may be asking a lot of questions with algebra, but I think you'll figure it out pretty quickly, so have some fun with it. Our learning goal is use patterns to show relationships and evaluate algebraic expressions. Here it is. Learning goal number 1 is to use patterns to show relationships and to evaluate algebraic expressions. So here is our example. Megan and Travis have the same birthday, but Travis is 6 years older. In the table below, M is Megan's age, and M plus 6 is Travis's age. Complete the table. So I think you've done tables like this before, and we're going to go ahead and do some math to figure those out. So you may want to go ahead and draw that table into your flip journal, please. So I've drawn the table for you. You know I don't draw very well with my bamboo tablet, but there's a kind of a sloppy little table up there. We're going to be using, we've got M, so when Megan is 3, when Megan is 5, and we don't know how old Megan is here. This is Travis right here, so it's going to be Megan's age plus 6. So if Megan's age is 3, then we're going to add 3 plus 6, which will give us 9. So right here, instead of this question mark, we would have a 9. Then here we go to Megan's age when she's 5. We're just filling in the actual number for the letter that it represents. 5 plus 6 is 11, so this would be an 11 in this space. And then this is 14. Well, we know that addition and subtraction are in the same family. So if this is M plus 6, let me show you. If M plus 6 equals 14, then we're going to subtract 14 minus 6 to find out what M is. 14 minus 6 is M, and so M in this case is going to equal 8 because 14 minus 6 is 8. So we would put an 8 in this table. Tables are fun and we use them a lot in algebra. We call them input-output tables sometimes. This is a table to help us to organize some expressions. So we're going to do some practice problems now. We're going to evaluate each expression for 2 different things. We're actually going to be solving each expression twice. And when it says to evaluate, that means to solve. So on lesson 6-1, we just wrote the expressions. Now we're going to evaluate them, which means find the answers for them. So the first time we evaluate the expression, we're going to do n equals 5. And the second time, we're going to do n equals 2. So let's see what our expression is. 12n. Well, we know from previous lessons that anytime we have a number next to the variable with no spaces between them, that means to multiply. So that means 12 times n. So we're going to have to do 12 times 5 and 12 times 2. Go ahead and do that and push play when you're ready. Did you write 60 and 24? Do you see how I color-coded those? For when n equals 5, the answer is 60, and when n equals 2, the answer is 24. Let's go ahead and see how we did that. Since I know that 12n means 12 times n, I'm going to rewrite it like that just so that it's a little bit more organized in my mind. Then the first time I'm going to substitute the number 5 for the letter n because that's what n stands for at this time. So I'm going to put 12 times 5 and then I'm just going to evaluate it. I know that 12 times 5 is 60. So 12n equals 60 when I'm doing this first problem. When I'm doing the second problem, let's see, we want to use red this time. 12 times n. N is going to equal 2, so I'll substitute 2 for that n. And 12 times 2 is 24. So in this case, when we evaluate it, our answer is 24. That's how we got 60 and 24. Now you're ready to work the rest of the problems without any help. Number 2, 50 minus n. First substitute it with n equals 5 and then n equals 2. Go ahead and push play when you're ready. Did you write 45 and 48? 50 minus 5 is 45. And then when I substitute in with 2, 50 minus 2 is 48. That's not too hard. I don't think we even need to show you that math. You're pretty good at that stuff. Let's try another one. This one we might need to work out. Number 3, 8 and 6/10 plus n. I wonder how hard that's going to be if we can just do that in our head too. Push play when you're ready. Did you write 13 and 6/10 and 10 and 6/10? Let's see, we don't have any decimal numbers with our 5 or with our 2, so we can just add the whole numbers and then add our decimal. 8 plus 5 is 13, and we still have 6/10 because we would have annexed a 0 in front of our 8. In front of our 5 to make that work out. Then when we add 8 and 6/10 plus 2, we add 8 plus 2 and get 10, and then just add our 6/10 to it. That wasn't hard at all, was it? Let's keep going. It's time to challenge yourself. A century is a period of time that is 100 years long. That C-E-N-T, cent, is actually a prefix that means 100. Write an expression that can be used to find the number of years in X centuries. We're using our X as our variable because X might be a different number. It might be a 6 one time, it might be an 8 another time. Go ahead and write your expression and then come back tomorrow ready to check your answer. Finishing up, make sure that you understand everything in this lesson. Give yourself a 1, a 2, or a 3, showing us how you're feeling about your learning. In your flip journal, write down any questions you still have, and I hope you're having fun with algebra. You have completed lesson 6-2, patterns and expressions. I can't wait to see you tomorrow.